Good morning. Today I am going to discuss polymers. Polymers are compounds having very high molecular mass called macromolecules, formed by the combination of large number of small or simple molecules called monomers. That means simple molecules, monomers, combine to form polymers. Polymer is a macromolecules. Macromolecules means it has got high molecular mass. Remember, all polymers are macromolecules, but all macromolecules are not polymers. For example, vitamin B12, your chlorophyll, or hemoglobin, these are single molecule. These are single molecule, but they have got high molecular mass. That means polymer is a macromolecules, but all macromolecules are not polymers. Now, next we shall proceed. What is called polymerization? It is a process. Polymerization is a process. Polymerization. The process by which simple molecules, that is monomers, are converted into polymers is called polymerization. जो process रे simple molecule, that is monomers, combine to form a macromolecule, that is called polymers, is called polymerization. There are two different ways by which polymerization takes place. One is called chain growth polymerization. It involves a chain reaction in which successive addition of monomers unit takes place, leading to growth of a chain. That means one molecule they combine to form a chain molecule. Example under this will be polyvinyl chloride, Teflon, or polythene, polyethylene, etc. This is one process. Second way is called step growth polymerization. Now, in this process what happens? Now, condensation of monomers takes place stepwise with elimination of simple molecules. Small molecules are eliminated from here. Example is nylon, your bakelite, etc. So, there are two different processes by which polymerization takes place. One is chain, one molecule combined to form a big chain. Stepwise means when condensation of molecules takes place, stepwise with elimination of small molecules, it is called step growth polymerization. Next we shall proceed to classification. classification of polymer takes place in 4 different ways. A, on the basis of sources, from which source you are getting, or origin you better tell, or origin. It can be bit 1, natural polymers obtained from plants or animals. That means nature provides you. Few examples under this head. I am writing the name of the polymers and its monomer. Polymer, its monomer. One is your starch. Your monomer is glucose. Second, cellulose. Here also monomer is glucose. Third is your protein. It is from alpha amino acids. Fourth one is your nucleic acids. It can be DNA or RNA. The monomer is nucleotides. So, in this class, on the basis of origin, one is a natural polymer which is obtained from nature, that is from plants or animals. The second one is synthetic, or B2, let us write B2, synthetic polymers. That means the polymers which are prepared artificially or in the laboratory are called synthetic polymers, which are now we are using to a large extent, like say PVC, polythene, nylon, etc. Under this head it will be polyvinyl chloride, or say Teflon, or say nylon, etc. These are man-made or prepared artificially, therefore we call it synthetic polymers. So this is one way from their origin, whether you get it from the nature or whether you prepare in the laboratory. The second way, on the basis of the second way of classification, basis of mode of synthesis, how you are synthesizing it, the process. It can be bit 1, an addition polymer. Addition polymers. Now, a polymer formed by the direct addition of monomers or the repeated unit without elimination of any unit, or they combine with each other without elimination of any small units. These are also sometimes called homopolymers because the same thing is repeated for large number of times, homopolymers. Examples here, polythene. Here ethylene is repeated for large number of times. Polyvinyl chloride. Here vinyl chloride is repeated for large number of times. So in this type of polymer addition, say you are taking X, etc., they add up. The second way under this head is condensation polymers. Here, a polymer is formed by the combination of monomers, not one, different monomers with the elimination of small molecules like water, ammonia, HCl, etc. These molecules are eliminated. Example, terylene, nylon, 6,6. So they condense. Two different monomers condense by eliminating small molecules like water, ammonia, HCl, etc. It is called condensation polymers. So the second way of classifying on the basis of how the polymerization takes place. The third way of classification of polymers is on the basis of structure. On the basis of structure. Number one, linear chain polymer. Now, these are polymers in which monomer units are interlinked, mixed together to form a linear chain. Linear chain. These linear polymers are well packed and therefore they have got high density, high tensile strength, and also high melting point. That means here the monomers combine to form a linear chain. They are well packed, therefore they have got high density, high tensile strength, high melting point. Example is under this head your polythene, nylon, etc. This is one way. The second comes under the head on the basis of structure is branched chain polymers. Now, these are polymers in which the monomers are joined to form a long chain having branches at different lengths. It forms also a long chain, but it has got branches at different points. So they are not well packed. These are irregularly packed and therefore have low tensile strength, and low melting point. Few examples are low density polyethylene. So they have got branches at different places. Third one is cross-linked polymers. Third is cross-linked polymers. Now, these are polymers in which monomer units are cross-linked to form a three-dimensional structure, to form a three-dimensional network. These polymers are hard, rigid, and brittle. Examples is bakelite, melamine, etc. So here the monomers combine to form a cross link having a three-dimensional structures. Therefore, it becomes hard, rigid, and brittle in nature. Examples is your bakelite, malamine, etc. This is another way. The fourth way of classification of polymers, I have told you 4 different ways, 3 I have already discussed. The fourth one is on the basis of molecular force. What type of force is there? Number 1 is elastomers. Now, polymers having elastic character is called elastomers. In these polymers, the polymer chains are held together by weakest force of attraction. That means there is weak force in between the molecules, which permits the polymer to be stretched. It can be stretched. Example is your vulcanized rubber. So, here the molecular force is weak, by which it can be easily stretched. Example, vulcanized rubber. Since it possesses elastic property, we call it elastomers. Second is fibers. Now, polymers which have strong intermolecular force. Here this force is strong intermolecular force between the monomer molecules, and give rise to, it gives fiber, suta, thread बढ़िया fibers. Example is your nylon, 6,6, Dacron, etc. So, here the force of attraction between the molecules is strong, giving thread-like structure or fiber-like structure. Therefore, we call it fibers. And example is nylon 6,6, not pronounced as 66, 6,6, Dacron, etc. Third one under this head is thermoplastics. Now, here the polymers which can be easily softened on heating. When you heat, it becomes soft, and on cooling, it becomes hard without changing much of its properties. That is, example we can have is polystyrene, polyethylene, etc. That means it can be molded. That means when you heat it becomes soft, on cooling it becomes hard, having or losing very little of its properties. That is called thermoplastics. The fourth one under this basis of molecular force is your thermosetting polymers. Now, here the polymers which undergo permanent change on heating. That means on cooling you cannot get back the same polymer. It undergoes a permanent change on heating. Examples is your bakelite, your malamine, etc. So, there are 4 different ways we can classify. One is on the basis of origin, second on the basis of formation, third on the basis of structure, fourth on the basis of molecular force. Now, I will going to give you different examples of synthetic polymers. So, under that head, I will give you the name of the polymer and the monomer from which it is formed, monomer, and the uses where we use. Number one is polythene, monomer is ethylene. It is used for packing materials, containers, bottle, and electrical insulators. The second one is your polyvinyl. Here the monomer I have told you ethylene. The second one is your polyvinyl chloride. In short, we write as PVC. The monomer is vinyl chloride. Monomer is vinyl chloride. And it is used for the manufacture of raincoats, handbags, plastic dolls, vinyl flooring, electrical insulator also, electrical insulators, pipes, etc. Now, in PVC, the monomer is vinyl chloride. We use to prepare raincoats, handbags, plastic dolls, vinyl flooring or plastic flooring sometimes called, and electrical insulators and preparation of pipes. Third one is neoprene. Here the monomer is chloroprene. Monomer is chloroprene. It is used for making containers for storing petrol, oil, and other solvents. It is also used for making hose pipes, shoe wheels, stoppers, etc. So, neoprene is obtained from chloroprene, used to prepare container for storing petrol, oil, and other solvents. We also use to prepare hose pipes, shoe heels, stopper, etc. Fourth one is Buna S. Buna S, capital S. Now, here there are two monomers in this case. One is butadiene, more correctly it is buta-1,3-diene and styrene. Monomers here, Buna S, Bu stands for butadiene, S for styrene. and it is used for making automobile tires, tubes, etc. Gunna S. Fifth one is quite important, very often it is asked, Teflon. Teflon. The monomer is tetrafluoroethylene. Tetrafluoroethylene. It is used for materials to have high, it is resistant. Teflon is resistant to heat, acid, alkali, etc. So, therefore, it is used to prepare materials which should be resistant to heat, acid, alkali, etc. Now, it is also used to prepare different cookwares, since it is non-sticky in nature. It is non-sticky in nature. So, Teflon is prepared from tetrafluoroethylene. It is resistant to heat, acid and alkali, therefore, we used the materials where we can store acid or alkali or which should be resistant to heat. Also, you used to prepare cookware since it is non-sticky in nature. Next, sixth one is your nylon 6. Nylon 6. Here monomer is caprolactam. Now, it is used for the manufacture of tire cords, it is used for the preparation for tire cords, also used for the preparation of fabrics, ropes, etc. So, caprolactam is the monomer of nylon 6. The seventh one is your nylon 6,6. Here are two monomers from which nylon 6,6 is prepared. One is hexamethylene diamine, another is and adipic acid. Since both of them contain 6,6 carbon atom, therefore, it is called nylon 6,6. It is used for making bristles for brushes, fibers in textile industry. So, nylon 6,6 is named as hexamethylene diamine contains 6 carbon atom, also adipic acid contains 6 carbon atom. So, two monomers hexamethylene diamine and adipic acid. It is used to prepare bristles for brushes, fibers used in textile industry. Backlight. Here the monomer is phenol and two monomers, formaldehyde. It is used to prepare combs, pania, used for making combs, phonographic records, gramophone records, phonographic records, electric switches, and handles of various utensils. So, baconite is prepared from two monomers, phenol and formaldehyde, used to prepare combs, phonographic records, gramophone records, electric switches, handles of various utensils. The ninth one is your polyacrylonitrile. Sometimes it is written as PAN. Here the monomer is acrylonitrile. It is used as a substitute for wool. Now, विभिन्न प्रकार कमल बजार देखुव, that is not prepared from wool, used as a substitute for wool. As a trend name, either we call it Orlon, ORLON, or acrylan. So it is used as a substitute for wool for making fibers. Trade name we give it Orlon or acrylan. The 10th one is polystyrene. Now, here the monomer is styrene. It is used for the manufacture of insulators, used as insulators, wrapping materials, manufacture of radio and TV cabinets. So, polystyrene monomer is styrene, and it is used as an insulators, also wrapping material, and also construction of radio and TV cabinets. The 11th one is your Bunna N. One thing I have also told Bunna S, but it is called now Bunna N. Here the monomer, it is also two monomer, buta 1,3-diene, butadiene, and acrylonitrile. It is used, it is resistant to oil. That means we can use as to store petrol or lubricants That means it is resistant to all these things. It is used also to construct oil seals, tank lining, etc. Since it is resistant to petrol, lubricant, etc., so it is used as oil seal, tank lining, etc. And the 12th one is terylene or dacron. Terylene or we call it dacron. The monomers here, monomer is ethylene glycol and terephthalic acid. Terephthalic acid. Here it is, we can prepare fibers here, so it is used for the preparation of fabrics since it is a wrinkle resistance. Wrinkle resistant. So these are the different types of polymers where I have given you the name of the monomers and its uses. Now you can find most of these polymers causes environmental hazards. These are not biodegradable. Therefore, it pollutes the environment, it causes health hazard to animals, also responsible for groundwater depletion. So now we have found the substitute for these polymers which are called biodegradable. Polymers which can be easily degraded by the environment. One such example is polybeta-hydroxy butyrate. Beta-hydroxy valerate. Now here monomers are 3-hydroxy butanoic acid and 3-hydroxy pentanoic acid. Now this, it is used for preparing specially packing material. It is used for packing materials. Also for orthopedic devices. So one of the biodegradable polymer is polybeta-hydroxybutyrate, co-beta-hydroxyvalerate. There are two monomers, 3-hydroxybutanoic acid and 3-hydroxypentanoic acid, used for specially for packing materials and orthopedic devices. Another biodegradable polymer is nylon 2 and nylon 6. Nylon 2, nylon 6. Now, here the monomer is glycine and caproic acid. It is used as an alternate or substitute. Is it used as a substitute for nylon 6 or nylon 6,6. So, these are the biodegradable polymers. So, this is all about the polymers.